Hello viewers, welcome to Jerry's Tech. Okay, in today's video I want to talk about a thermostatic expansion valve. As you can see, this valve is for, these are the datas, is meant for R22 and R407. Please, it's very important to note that you when you are replacing your valve, your TSVs, or you want to make a replacement, or maybe you want to retrofit your system, please, the gas, the refrigerant that is in use, is the expansion valve that you purchase should be similar to the one that the refrigerant that you are about to use in the system. All right, explaining about this guy, a brief overview. As you can see, it's made up of this is a diaphragm. This very unit is a diaphragm housing. This diaphragm, it expands. It's like a push. How do I put it? It pushes open and also retracts to close, because this valve is a spring loaded. There's a spring here, there's a tension spring here, so it pushes against the spring inside to open, and also the spring helps it to close as the refrigerant in this very bulb retracts. So this is the sensing bulb and also the capillary tube. As you can see, this is the sensing bulb and this is the capillary tube. In this sensing bulb, we have a refrigerant being filled in it. Most often than not, you have the same refrigerant that is the expansion valve is being made for is filled in here, because this will help it to sense the boiling point, because there's a rated boiling point for those refrigerants. So as this very guy is being clamped to the return line, it's always usually clamped to the evaporator return line to the compressor, that is the low pressure side. So it senses the temperature on that very line in order to ascertain when the line is when the temperature increases and when the temperature decreases. So as the temperature increases on this very line, what happens is that the refrigerant here expands, and as it expands, it pressurizes this diaphragm downward, and by so doing, if you check, there is a needle there. It pushes that needle downward in this very if you can see, if you can sight that needle, it pushes it downward. So what happens now is that this very needle pushes this very valve. This is a needle valve, as you can see. It pushes it down, and when it retracts, this valve closes, and there is always a standby refrigerant, liquid refrigerant from the condenser area. It comes here. This is the strainer. It stays here. There's a liquid refrigerant here always, and as that needle compresses this very valve, the refrigerant is escapes and goes through this very port to the evaporator. So this guy, his purpose is to regulate the pressure in the evaporator, because it's not right to allow your refrigerant comes from the compressor through the condenser and direct to your evaporator. So this guy is the middleman to do the regulation. And this very port here that you see here is a equalizing port. There is a line that is being attached here. There is a pipe, a pressure line that is being attached here to the suction, the low pressure side, that is the output of the evaporator where this bulb is being clamped to. So that pressure also from the line comes here in order to act on this diaphragm in case if there is much pressure on that return line. So it acts on this diaphragm including the tension spring. This is okay. I'll go to the tension spring later. After it acts on this diaphragm in order to oppose the opening when there is more pressure. The temperature, this guy also is also sensing if the pressure is much, it acts against the opening of this guy, because if this is warmer it tries to open, then but the pressure is much there, it will act to close, to try to regulate and close the diaphragm, the actuation of the needle. So this is a tension spring, because normally as the diaphragm acts downward, there must be a spring to to go against, to counteract the movement of the needle, that I showed you guys earlier. So to adjust this is where, if you want to open more, you want more refrigerant in your evaporator, then you have to crank this open. A quarter ton only should be enough. You crank a quarter ton first, and you wait and observe your system to see if everything is okay or not. If you want to close, maybe you are having flooding and all that, you close a quarter ton as well. But you are not advised to regulate this, because this is already being adjusted in the factory where it was manufactured. So for anybody going to regulate this, must be a trained person, someone that understands the system very well. So you are not advised to open this. So this very bulb is being clamped to the pipe. See, with this clip, you secure it strongly to the evaporator a low side. That is the return line that is going to the return pipe that is going to the compressor. This is where you clamp this guy here, and as you can see, this is the strainer. We have the strainer here that filters the gas, filters the refrigerants and all that. Okay, I think I'll be able to make a brief explanation about this thermostatic expansion valve. Please like, share, and also comment if there is any question that you have, or you want to, there is any contribution. Please do drop your contribution and your comments. Thank you. Please subscribe to encourage me more. Thank you. See you in my next video. Bye.